Hey friends, welcome. So here today we're just going to go through a quick lecture on soil. We've got a lot more to talk about with soil, but we've got to just understand what are we talking about when we're talking about soil, right? Like this question, what even is soil? We've all heard this term probably our whole life, and we could probably talk about it, right? If we go out in the park, soil's the brown stuff, it's what plants grow in. But it's so much more complex than most of us even realize. There's so much going on in soil. So, at a basic level, if you were to write this definition down, it would be hint, hint, that soil is a mixture of organic matter, minerals, gases, liquids, and organisms that support life. There is this complexity and this piece here that is so important about organic matter. Healthy soil, if some of you guys remember studying Central Park, many of you pulled this piece of evidence that talked about the level of biodiversity in the soil of Central Park. There are so many microscopic bacterial organisms, and all of those organisms live in soil. They add nutrients, they add oxygen, they add carbon dioxide and other gases into soil, and they hold the soil together. And all of these things together support more complex life like plants, and then of course our consumers live off of those plants. So soil is a complex mixture of life and organic matter, as well as mineral elements such as broken down rock. So how does soil get here? Soil starts from rock. At the heart, soil requires tiny, tiny broken down particles of rock that have been weathered and eroded into these tiny sediments. There are 5 factors that drive soil formation. So number 1 is the type of parent material. So there's a lot of different type of rock, right? We've got limestone rock and sulfur and probably many others that hopefully you learned about in earth science last year. As this rock breaks down, it has particular chemical characteristics, and those chemical characteristics stay with the soil, and it will forever have similar characteristics to its what we call parent material, which was the rock that it formed from. The ability of this to form really depends on climate. So the higher the moisture content, etc., the more likely you are to experience weathering of the rock, more likely that the rock breaks down and creates soil, as well as if you have conditions that are ideal for certain types of bacteria or lichen that break down the rock further. Topography matters. Topography is just the shape of the land. So if the land is flat versus if the land is sloped. If you think about if you're on a hill and what the material weathers down, but then the hill causes all of that to be eroded away with the water, none of that broken down soil material stays there, versus on a flatter surface, you're likely to have the soil be able to stay on top of that rock. And as you can see in this picture, the eroding rock that breaks down into the soil or those minerals just kind of sits on top and builds on top of the parent bedrock. Again, we have those biological factors that I talked about. So things like the lichen and the bacteria that make up that soil, they continue to erode away at the rock and break it down, as well as add in the gases and some of the other aspects that make soil something that can support life. And then obviously is just time. It takes 2,000 years really for a small amount of soil to form. So it's a really, really slow process, certainly faster than other processes that we might know about, but it just takes a long time for an area that used to be rock to develop a healthy layer of soil. You can see that ended up developing into layers, so we have to talk about soil horizons. Soil horizons, sometimes called a soil profile, are really just the layers that we saw in that last image. And they're pretty predictable. At the bottom is unweathered parent material. So anywhere you go on Earth, if you go deep enough, there is a layer of bedrock, and that rock is solid. The rock on top of that has weathered and begins to make the soil horizons. So the topmost soil horizon is what we call the O, or the organic horizon. This is where you've got all of your recently dead organisms, plants, etc., that begin to decay. So it's really, really rich in organic matter and often really, really rich in nutrients. And we call this, when organic matter breaks down, it creates this really dark, rich, teeming type of soil that we call humus. Some people call it hummus. I always grew up calling it humus. And that in soil horizon A is some of the mineral matter from the broken down parent rock mixed with that organic humus material. So again, a really rich type of soil, often called the topsoil. And so topsoil is what farmers really care about when they're growing. Underneath this, you have, I missed it. We'll talk about the B soil horizon because this is the next one you need to know about with the AP, which is the subsoil. So this is the soil that's going to have a lot more clay, a lot more parent material in it, very little organic material at this level. And the C, you're going to have mostly, that's the substrata layer, you're going to have mostly parent material. Some of that won't be even fully broken down, so you'll have larger amounts of like rock chunks mixed in with the fully broken down material there. So when we break this down, one of the things that's going to be really important for you on the AP is that if you were asked about how much organic material you could expect to find in any of these layers or how much parent material you would expect to find, you would understand the higher we are in the soil layers, the more organic matter. The lower we get, the less organic matter, but the more parent material. So this is soil. Now we're going to talk about what makes soil healthy, how and what happens when soil is not healthy, and how have humans disrupted soil.